0.5 and 4. Very quickly plot. 1, 1. You should be excellent plotter, if there's such a word. 0.59. So close to 0.6. Okay, somewhere here. 1.5. 0.44. Okay, somewhere here. 2 and 0.25 here. 2.5 and 0.16 somewhere here. 0.1 here. Okay, so go and plot out the points. Estimate where the 0.16 is. So 1.5 box slightly above. So this is how the curve looks like. Y equals to 1 over x squared. Hello. Party ah. Okay, so actually, right, if you were to plot the other side of the graph out, okay, the graph on this side will look like this. Okay, like the boomerang. Okay, so this is the typical shape of a 1 over x squared graph. Or we can say x to the power of minus 2 graph. So this is the full shape. But sometimes they ask you to ignore the x less than 0 and just show this part. So this is the curve and how it should look like. If you plot it out, you definitely know the shape. But you're supposed to memorize the shape.
So it's always like symmetrical?
Yes.
So 1 will be greater than 0, 1 will be less than 0?
Yes. Okay? So they ask you to observe what will happen to the value of y as x increases. So when x becomes bigger and bigger, what happened to the value of y? It becomes smaller and smaller until it is like almost touching the y-axis. So you can say that y becomes, value of y and approaches 0. Okay, the key word is approaches. Okay, approaches means it will go infinitely very, very near to 0, but it will never touch it. So now I'm going to introduce you to this word. Okay, called the asymptote. Okay, asymptote is a line where your curve... There? Okay, it is a line where your graph approaches but will never touch it. Okay, it is actually the value that your graph is undefined. So this is the place where if your x becomes very big, right? The 1 divided by a very big number. Imagine you have one big pizza and you need to share it with infinitely many people. Then the pizza you get gets smaller and smaller, but you will always get one small piece. Yes.
There's no real rules.
No solution, okay? So it is never the case where you will ever get x equals to 0. So, in other words, this line here, okay, this line here is also the asymptote. Yes. Okay, so asymptote, can you see that your graph, when you draw, right, never touches. So that means if I plot, I keep plotting, this graph will go very, very, very near to the y-axis, but it will never eventually touch it. Because this graph, the solution here cannot ever have y equals to 0. it can never ever reach x equals to 0 as well. Okay, because you see, can I get x as 0? Do I have a solution when I sub x as 0? It's impossible. It will be undefined because the graph will never hit 0. Same thing here. Is there a chance where my y is 0, and then can I ever solve it? I cannot, right? So there's no solution for x equals to 0 and y equals to 0. In this case, your graph will always look like it goes very near to it, but it will never touch it. So in this case, the x and the y axis are the asymptotes. Okay? Your graph approach it, but it will never touch it.
Is there an end to the graph? Or it just...
No. If you keep zooming in your graph, right, it will just get closer, but it will never touch it. Yes. Never. Okay? So that means when I ask for your sketch, right? When I ask for your sketch, you don't draw like that. Then I will circle like that. Wrong. Because when you sketch it, it should go very near, but it shouldn't ever touch it. So make sure it does not touch. This is the important thing. Okay, once you draw that it touches, I mark wrong already because that means you don't understand how the graph looks like. Can yx never equals to 0. You see, the fraction will become undefined. So there's no solution.
So it can't be 0.
Yeah, so it will never touch.
So there's no intercept.
No intercept. I don't know why my brain was not functioning just now. I just realized my mistake. If it's a x squared, there's no chance that you can get negative, right? So both must be here. Aiyo. I just realized. So it must be like that, like the volcano. Because x squared, all the negative will be going up. Okay, next graph. Now is the exciting part.
So it's never 0.
Yeah.
Why x never equals 0?
Okay, here. Okay, the one that we are familiar with is n equals to 0. This is the one that we are familiar with, power 0. Because it just means that your y is a horizontal line when a is positive. Okay, when a is negative, it is below. That's all. This one we learned before already. Horizontal line.
Y is y next to horizontal.
Because when n is equal to 0, this is equal to 1. So it's gone. Okay, so power 0 is just a horizontal line. What you have learned before. Okay, this one is what you have learned before also. Power 1. So can you see that it is like your y equals to mx plus c? Where 3 0 on the left? Oh, negative 3. Sorry. I never see. Okay, never mind lah. We change this one. Positive. This one change to negative. Okay, next one. Can you see that this is just your linear graph? When your gradient is positive, it goes upward. Gradient positive. When your gradient is negative, it goes downward. And the y-intercept is 0. Yes. Because x to the power of 0 is 1, right? So actually, they ask you to draw y equals to a. So when y equals to 3, it's a horizontal line on top. When y equals to minus 3, it's a horizontal line below. Yes. Okay? So this one you have learned. Another one you have learned is this one. X squared. So remember when a is positive, it's a Smiley curve. So this is quadratic graph. So all these you have learned before. So this one is nothing new. Then this one is the frowning curve. Okay? So this is quadratic, this is linear, this is a straight line graph. Or rather horizontal graph. So this, although they say there's 6 graphs here, these 3 we have learned before. The other one is just a mirror image. Okay? So this one you learned before already, nothing new.
So you were talking about the zip codes, right? Something about if you give a slice of pizza.
Yes.
So you're saying we should have a pizza party at Anamia, right?
If everyone passes, can we get?
You always catch the wrong point, right?
All in favor?
Okay, never mind. Okay, just now, we just mentioned that if x is to the power of minus 2, it will become this. Right? Just now we mentioned this already. Yes. Remember y equals to mx plus c? It's either an upward slope or a downward slope. So this one, gradient positive, means it's upward.
Wait, Miss Wong. Oh, no. Why they keep the negative?
Yes, A is gradient. Yes.
Why is the negative 1 going up but the positive 1 going down?
Negative 1 going up. Where got?
No, the negative for AX shouldn't it be going down?
No, when the gradient is positive, it goes up. A is like your gradient.
But isn't the gradient negative?
Where gradient negative? No, on top I changed to positive and negative. Easier to see.
Wait, then Miss Wong.
This one, change.
Shouldn't it also be this?
Yeah, change that. Okay, so just now, you just plotted the first graph. And we have shown you that if it is y equals to 1 over x squared, if you plot it out, it will look like this. Okay? So if A is positive, this one, A is positive. Then this is how the graph should look like. And if I make the A negative, let's say I make the Y negative. So this is positive, this is negative, right? So all the positive Y becomes negative. All the negative Y becomes positive. So we are expecting a mirror image. So this part here goes down. And the other part here goes up. So it's a reflection. Okay, can you see this part? This one here, reflected below. This one here, reflected on top. Okay, so it's a reflection. The positive Y becomes negative. The negative Y becomes positive. So there's a reflection here.
What if A is a real number? Like it's not 1.
Doesn't matter. As long as it's positive, it's this shape.
Oh, it's shape.
Yes.
But the points will be separate.
It will be like steeper. Yeah. Okay? So, I drew the wrong one. Okay, I'm sorry. So sorry, this one. Here should be on top. Okay, my bad. This one here should be on top.
Why is the x squared up and not down?
Like that.
Right? Even number, both slopes are together.
Yes.
But odd number, they're different.
Correct. Okay, you just imagine your table of value. Let's say your x is 1. And then your y, right, is 1 over 1 square. So this is 1. Okay, when this is 2, this one will be 1/4. It gets smaller and smaller, right? But what if you put in a negative number? Can you see that it still become positive? So that's why on this side, it is also on the top part. Because when you square it, it will become positive. Okay, then this is the one that will be like this. Okay, no wonder. Okay, then this is the other one that you will flip. So for y equals to a over x power 1, it is split in this way. Okay, it's split in this way. Okay, your dancing is like this. Yeah.
It's cube, right? Then it's also the same shape as one. Negative one.
No, cube is a bit like this. Yes. Because it cannot be equal to 0, it will be undefined. So this one is an asymptote. This one also asymptote. Because, you see, a cannot be over 0, it's undefined. You also can have no chance where this is equal to 0. No solution. Yeah. Yes. You need to memorize all the shape. So just remember one, and then the other one is a reflection. Okay, the very last one you need to memorize is this one. And then a reflection, x cube graph. Okay, this is a x cube graph. So total they say there is like 14 graphs to memorize. Here there's 12. Here there's 12, right? Because 6, then you reflect, so 12. There's another one that's exponential, which is behind. So total you will learn 14. This is 12. Okay, and then A math, you have logarithm graph, sine graph, cosine graph, tangent graph. Yes?
Why isn't a greater than 0?
It just means positive value or negative value. Yeah. Can Yes. This one, all these are, if you ask me why is the shape like that, when you go and plot out the graph, this is how the shape becomes. Yeah. So, just to prove to you, see whether you get a y-intercept or x-intercept or not.
If it's like
If it is, then it passes through. You sub in x at 0, see got solution or not? Yeah. Yes. Okay, can or not? Can
Can it be at a different point?
Just draw this shape and then get steeper. Just draw that it gets steeper, can already?
So the increasing number is more.
Yes, make it steeper and steeper because it's increasing faster. Okay, when it's negative, concept. Okay, next one. This one, both below. Just now we figure out it's either both above or both below. Which graph should it represent? Which one? I got 2 here, 6 or 9? 9 because it's negative. Okay, so you must know how to match. This one? One on top, one below. Which one should it be? We have these two to choose from. Is it the positive one or is it the negative one? Yes. So you all must know how to memorize the shape. When it's 1 over x power 1, it is like this. When it's negative 1 over power 1, is the other side. When it's 1 over x squared, both are on top. When it's negative 1 over x squared, both below. So go and memorize these shapes. When it's x cubed, positive, it's like this. Negative, the other side. Okay? X to the power 1 positive going up. Oops. Okay, x to the power 1 negative going down. Okay, it's all the typical ones. X squared, smiley curve. Negative x squared, frowning curve. So all this shape, when you see the power, you must know what kind of shape we are talking about. Then it's not difficult at all. Yes. No, this one I change on top. This one cancel out.
Did you change?
This one is positive. This one negative.
Oh, okay.
So cross this out.
Okay.
Okay. My lesson 11:40. Oh, no time. Okay, can I leave you to try example 2, 3, 4 at home? This is the suitable line that you need to solve. Okay, this one, go home and plot. And then this is the one that will be tested in WA, which is the suitable line. Okay, so this is the important thing. And find the suitable line for me. Make this relate to this. So can you see that this is y?
Plus 2x.
So put the y here. Leave the 4 minus x here. Bring the 2x to the other side. So the equation you need to draw is this one. This is the suitable line. So this time round, your graph plotting, we have quite a bit of marks. Please make sure you know how to do the suitable line. The plotting, 2 marks. Filling table of value, 1 mark. No, plotting could be 3. So 4. And then reading 5. Suitable line plus draw 7. I don't think so. That one last WA.
Power 1 is the up, then power 0.
Power 0 horizontal.
Power 2 is the
Yes.
then power 3 is the
Like that.
then negative 1 is the
Split like that.
power 2 is the
Then this one is the square. Let's start from the first one. Ready or not? You're not even on the table.
thermodynamics.
Ravan, you need to stop looking at Skylar. Then throw back. Okay, finish it. Okay, look front. Okay, if you don't turn back, then Skylar, stop disturbing Ravan. Okay, please. Okay, let's finish this. Okay, substitution, I believe I don't have to go through anymore. If you sub in x here, you will get 8. This one is page 5. Okay, and then if you sub in 5, you will get 0.8. So they will usually give you 1 mark for completing the table. Okay, that's the first one. Then next, they will ask you to plot. So plot, I mentioned before, they give 3 marks for it. So A for the axis, P for the plot, and C or S for the smoothness of the curve. Is it flickering? Okay, so 3 marks, but sometimes if they already gave you the scale, then at most they will award 2 marks for you only. That means if they already wrote all the markings for you, then you are done lah. Okay, they won't give you a mark for this. So 2 cm for 1 unit on the x-axis. So 2 cm is 2 box for 1 unit. So you will go all the way until 5. Oh, I got too much. Sorry, my eyes. 2, 3, 4, 5. So x-axis. Y-axis is every 2 cm is 2 unit. So 2, 4, 6, 8, 10, 12, 14, 16. Okay, so you plot out the points. 0.25 to 16. So probably here. Okay, 0.5 to 8. Okay, and then 1 to 4. 1.5 to 2.7. So here. Okay, and then we have 2, 2. 3 and 1.3. 4 and 1. 5 and 0.8. So you plot it to the best of your ability and then pass your curve through the points. Okay, so when they ask you to draw this, you know this is a 4/x graph where your y-axis and your x-axis are the asymptotes. Meaning your curve approach the line but will never cross it. Okay, so when you see a curve like that, before you learn this chapter, all these shapes will look eccentric to you, but now it should be normal because you know how it should look like. In fact, when you look at the equation, you should guess the shape already. Okay? So once you plot, that's a 3 mark. 1 mark for getting these two right. And then another 3 marks here. So that's 4 marks already. Okay, next one, they say, can you draw a suitable line so that you can solve this? Okay, so yesterday we spoke about that, but let me redo this part. Okay, so this is the question that they want you to solve. Okay, this is the question they want you to solve. So you need to relate back to the original equation. So the original equation is this one. And somehow you can already see it here. So if you keep this there and shift the others over, let's say you plus 2x on both sides. So you will be left with this on the left and then 2x on the right. So this part here is your curve. The curve that you have drawn here. Okay, this part is the curve that you have drawn here. And then you want it to be equal to 2x. So I already know that this thing here is y equals to 4/x. So I change this to y. This is the suitable line that I need to draw, so that I find the solution. Okay, so once I see this, you will get your method mark. Okay, for being able to do this. But sometimes, even when they see this, they don't give you the mark yet. They want you to draw it out first. So when you draw out this line, you need to create a table of values. Sub in any 2x value you can see here. Okay, so in your given range, you only have 0 to 5 to choose from. Don't go and choose 10 because it's out of your scale. So any number you like. So let's say I choose 0. When I sub in 0, this is 0. The other one, maybe I just sub in 2. So I will get 4. So I just have to plot out these 2 points. 0, 0, and 2, 4. And then I will draw that line out. So this is the equation that says y equals to 2x. So once you draw this, okay, you will get the mark. So what they want you to do is they want you to solve this thing, which means they want you to equate the curve to the line. So they want you to read the solution here. So you go and read it carefully. I think the x here is 1.45. Sorry? It depends. So sometimes it depends on the accuracy. So here, the x value that you are solving is x equals to 1.45. That's it. They don't need the y value. Okay? So label in your answer, this is part C. Yes. Because when we solve this equation is in terms of x, there's no y value involved. So don't need to give them the y. So the only thing that is new here is this part, which I taught y'all when we learned how to draw quadratic graph. Just that now it can be anything. And the graph that you are plotting can be any curves. Yes.
Where you got from 4/x is equal to 2x to y equal to 2.
This equation is y equals to 4/x, so I just change it back to y.
Oh, because 4/x is just
Y, yes. Okay, so this is the suitable line. Usually, this is the question that traps most of the students. this last one. But if you can do the whole graph question, 5 to 6 marks is all yours. Okay, so please make sure you plot. Okay, if you are a person who take a long time plotting, please try to do the plot first. Quickly go and plot it out. Or you do what you can already. Then when you look at the time, left 10 already or 15 minutes, quickly go and do the graph. Then you move on to other part. Okay, don't waste your chance on the graph because plotting already gives you marks. Okay, even if it's not smooth, at least you get 2 marks out of the 3. Can so this is the curve. Okay, let's do more. I can, okay. Okay, if yours is slightly off, like maybe it's a 1.4 or 1.5, you will still get the mark. Example 3, example 4. These 3 homework. Go home. Okay. Okay, here. Now it's just finding the suitable line. This is my original. The one that I already plotted out that you see on the diagram. Then they say, can you solve this? So you know you need to make use of this equation and relate back to the original. So let me pull this out. So you need to remember that your ultimate goal is to have the left hand side equals to this thing. So definitely the 3 minus, the negative 3 over x squared is done. I will keep it here. There's only 4 that is not supposed to be there. So what should I minus on both sides? I want to make the left hand side of the equation equals to my original. So now I have a 2 here. This is a 4. So I need to make sure this is 2. So I subtract 2 on both sides first. So you will end up having the left hand side looking like this, which is your original curve. Okay, can you see this is your original curve? It's exactly this one. Yes. So this curve is what you have drawn out. You want it to be equal to x minus 2. So this curve is y, right? So this is the suitable line.
How do you get x minus 2?
The x was already there here. I never changed anything. I just copy down what they want me to solve. But I need to make the left hand side looking like my original. So I minus 2 on both sides. So always start off with here. What they want you to solve. Okay, start off with here. And your ultimate goal is that the left hand side of your expression must become your original curve. Okay, so the last 2 marks, if you want it, this one you must know how to do. Yes.
I thought like there's x squared not plus the
X square?
equation.
Yeah, why?
You told that there's x squared cannot substitute.
Yeah, but because this is a addition of 2 shapes, so it's slightly different. Yeah. Okay, so suitable line is y equals to x minus 2. So we will draw this out. Sub in x as 0, you get minus 2. Sub in x as, oh, minus 2 is out, right? So maybe we cannot use this value. Let's use 0.5, or also out. 2 and 0. Okay, and maybe 1 and negative 1. Okay, so 2, 0 is here. 1 and negative 1 is here. Yes. You pick the value from 0 to 5. But when you sub in, your y is out of range. You don't want to use that value because you cannot plot it out. Yeah. So these are the 2 points that I've selected. So go and join them together. Okay, so this is the line that you have drawn. Okay, and then where is the solution? It's right over here. So the solution is x equals to 1. Okay, so this is the solution. Okay, so your goal is to get the suitable line out. Yes. Oh, there's got one more. One more here. So you go and read this one. So it was 7, right? Or 3.8? 3.85.
Wait, Miss Ron, I still don't get the first one.
Okay, wait Okay, you see the question say, solve this.
Yeah.
So if they ask you to solve this, you must relate to the graph. If not, why did they ask you to draw the graph at all? So you must relate back to this graph. So this graph, the equation is 2 minus 3 over x squared. So I need to make this exactly the same as this. If not, I cannot relate back to the graph. So what I need to do is I need to minus the 2 away. Yes. Yeah, can. Sorry? Because I want to make this look like this. So it's 2. So when I do that, then my curve is out. This is my curve. So I need my curve to be equal to this line.
Oh, then y is equal to x.
Yes. Then you draw that line out. Okay, go. So why every lesson which lesson you don't go toilet? And it's always fill bottle. I asked you to buy the 1 liter one, right? This one not enough for you. I buy for you. Yeah.
For coordinates, I don't know how to.
Okay. So this one, right? You pick any value from 0 to 5. So just now I tried with the safest one. I tried 0, right? Then I want to put in here, my y will be minus 2. But I cannot plot because minus 2 is here. So I decided this one cannot use. Choose another one.
Must be in the graph.
Yes. So that's why I choose 2 because 2 minus 2 is 0 and it's within the graph. I can plot. Yeah, so you can choose any x value but make sure your y is in the range. Okay, if not you can't plot. Yes.
For the shoelace method, it is bottom left, right? Then you put that the slides, then it goes
Go and do the package.
up.
Then you will know. Okay? Don't ask me now. Yes. What? Okay, we will go through that tomorrow. Yes. Okay, we will do that tomorrow. Okay? Yes. Okay, I can choose 3. Any number that is from 0 to 5. So if I choose 3, I put the 3 here, I get 1. I also can plot this point out. So 3, 1 is here. Can you see? It's still on the line. Any 2. Just pick any 2 x values up in and plot it out. Yeah. Okay, next one. Okay, I have plotted this. And then the question say, can you solve this for me? So this one super easy. The left hand side is already the curve. Can you see? The left hand side is already the curve. I don't need to do anything about it. I just need to draw the suitable line out. So this is the suitable line. So I go and plot table of values. So any x values from minus 2 to 2 I can choose. So let's say, yes?
Then what do we do with the negatives 2 to x?
Negative what?
Negative 2 less than x. 2.
No, this one just tells me my x value is from negative 2 to 2.
Oh.
That's why I plot my graph from, yeah, that's all. Okay, so I pick, let's say I pick minus 1. Then this one will become minus 8. Then you look at your graph, can plot or not. If can, you keep the point. Then next one, maybe you use 0. So if you sub in 0, y is 0. So that point can plot. Then good enough. 2 points is good enough for a straight line. But if you want to plot all, you can. But no need, waste time. So minus 1, minus 8 is here. And then 0, 0 is here. So go ahead and draw the line out. Okay, and find the points of intersection. Okay, so one solution is here. X is 0.5. Another solution is here. 1.6, 1.7, 1.725.
This one?
Yes.
For this one, you don't have to like minus For the ester.
Because they already give me so nicely. I don't even need to change anything. Yeah, but rare lah. Usually need to do a bit. Okay, then actually if your graph draws beyond here, there's one more solution here. But because they never ask you to draw until that point, then you just stop there. You only have two solutions. Oh no, got one more here. No more already. So two solution in this case in this range. Then you show them both the solution. That's all.
So you write x equals half or x equals 1.
Correct. These two.
But if the graph extended a little
If this one they ask you to draw until maybe like minus 2.5, then most likely you have one more solution here. But because they ask you to cut at minus 2, your solution is only up till that point. So don't need to go and read that point out.
So like when you're drawing graph, you shouldn't draw extra.
Usually we keep to the range they want.
Okay.
Yeah. Okay? Can So suitable line is the only new thing, but it's not totally new to you. Yes. Can. Also, is it very obvious? 1.7. I think we will accept the range. Yes. 6 2 off. Because this every 2 box is 0.1, so this is 1.6. This is 1.7 already. Yeah, so 2 off. Yeah, too far off. You see? Jeff, can you stare at them? Tell your friend to look forward. I need to buy the hammer you inflate one, right? Then I throw over. Yeah, Ravan, I'm talking to you. Don't turn behind. No matter how irresistible Skylar is.
Me and Ravan just swap seats.
Skylar, you keep throwing, right? I tell Mrs. Leong. You leader, right? You play aeroplane in the class.
Means I think me and Ravan need to change seats.
No, you go there also gone. I can add one table here. This one VIP. I upgrade your seat. Then stop turning behind. Yes.
It'll go for short.
Which line? This line? No, the line will be the same line. Just that your points are different. You join at a different point. No, it must be accurate. Don't give me anger. Okay, so, shh. Just very quickly, what do you think a suitable value of A should be if your graph is at the bottom? Any negative number, you give me negative 100 also correct. This is just one possibility. Okay, what is the graph representing this one? Negative straight line. Yeah, so figure 4, this one, right? Okay, what about this one? So if you can capture the essence, it's quite easy. This one? Both on top, so figure 2. No, they look at the answer at the side. This one. Okay, the next thing is exponential function. This one, you will learn one whole chapter in E-math. In A-math, called exponential and logarithm. So, exponential graph. Yeah? This is not tested. Okay? Your E-math only tests until 5.1. So, you won't see exponential graph that looks something like that. Learn first lah, learn first.
Can we go to revision already?
Yes.
Can you revise, please?
Revision.
Then after exam, then we come. We can't do this.
Yeah.
To look like this. So far, all the graphs that you have seen, right? All has the x, okay, as the base number. And then you have different power n here. Okay? So this one is the power. And then your x is the variable. But exponential is a bit different. Exponential is that the power is the x. Okay, so the variable is in the power. your x appears in the power, in the exponent. Okay? But all the others you have learned, all the x is as the base number. Just take note of the difference. So what kind of graph will you see? You will see y equals to 2 to the power of x. Okay, you see we have y equals to x squared, y equals to 5x, y equals to x cubed or minus x cubed, y equals to minus 5 over x, and y equals to 3 over x squared. Can you see the 6 types of graph that you have learned? Or no, only, or rather y equals to maybe 10. So the 6 types of graph: the straight line, the linear, the quadratic, the cubic, and then the odd power function, reciprocal function, the even power reciprocal function. So 6 types that you have learned. The commonality is the base number is x. Okay, but when the x becomes the power, then it is an exponential graph. So when you start seeing that the power is x value, then it becomes an exponential graph already. Can you see the difference between the 6 types we have learned and the new one that we are about to learn? So the k, the power is the variable. So here you see k is the constant. Constant means any number you can think of. Okay, then y is equals to kax with a base a. So now your base is a constant number. It's not an x anymore. So for instance, right, when you want to draw this, y equals to a to the power of 2 to the power of x, there's one very important point you need to know, which is called the y-intercept. So what do we sub in when we want to find y-intercept?
X equals 0.
Okay, so when you sub x equals to 0, what happened to this y value? 1, right? So all exponential graph, when there's no number in front, it always cuts through 1. Okay? And then every other value, right, that you sub in, if you have 2 to the power of 1, 2 to the power of 2, 2 to the power of 3, it gets bigger and bigger very quickly. So when you say something grows exponentially, it increases at a very fast pace. So it shoots up in this way, and then it slows down. Okay, no matter how small an x value you sub in as the power, right, you will never get 0. You try 2 to the power of 0, 0, 0, 0.000000001 or what? How many 0 you can put in? So 2 to the power of 0.00 or negative 0. Don't know what. You just think of any number that is small enough on the extreme end. You raise it to that power, you will never get 0. So for exponential graph, it will always lie above the x-axis. Yes. Yeah, the x-axis. So this is your y equals to 2 to the power of x.
Can you put a power to a power?
Power to, then it will shoot up even faster. Okay, so exponential graph, the trait is this. When you have power x, it will cut the y-intercept at 1. This value is always 1. Okay, and then it's an exponential graph that will never touch the y-axis. It is always positive.
Miss Mom, is this graph accurate?
Mine is of course not as accurate as Desmos. Yes.
What if the 2 is negative?
If I put a negative in front, that means I'm multiplying this graph by a negative number. Then of course the whole graph will flip downward. And then I will get y equals to negative 2 to the power of x. Because y, actually what I'm doing is I'm multiplying this whole thing by negative 1. So I'm flipping the graph downward. So now it cuts at minus 1, no?
It
Okay?
doesn't reach 0.
Which one?
Doesn't reach 0.
No, it will never touch the x-axis.
So we'll just keep it.
Correct. It will get very, very close, but it will never touch.
Will it shoot back up?
Yes.
I meant that like the negative bracket and then to
-2 bracket. Okay, I'm going to show you how the graph will change on the one thing that they mentioned is that the curve approaches the x-axis, okay, but never touches it. The values of y are always positive. So your entire graph is always above the x-axis. If you flip below, this one is like just now your 2x. Yes. No, can be 3x. Okay, change the number, doesn't matter. Then let's say this one is you put a negative at the bottom. Okay, then you flip downward, right? It shows that it also approaches the x-axis but don't touch it. Okay, and the values are always negative because the whole graph is below the x-axis.
This one.
Yes.
2 point, this chapter is until 5.1, right?
Yes,
5.1 is
only
until-
test until 5.1.
It's until where?
All the 6 types of graph that we talk about and the suitable line.
Oh, so this one not.
This one not tested. That means you won't see this shape.
The discriminant is always 0.
No real roots. If you try to solve it. Okay, done? Yes. How do you, oh no, it can be anything, can be 3. I just giving you an example. Okay, so notice that the power is x and then the base number is any constant. No, flip the other side, then minus. If you put y equals to 3 to the power minus x, then it flips this way. Because positive x is here, negative x is on the other side. So it will flip. Sorry? No need, but I'm just telling you, if this one becomes negative, then it's a mirror image about the y-axis. If the y value becomes negative, then you're flipping downward. Okay, just take note of the difference. Only at most these 3 types, flip this way or flip downward. That's all.
What about okay?
That one is x squared, 1 over x squared, right? Can I? Okay, so this one is just memorizing the shape will do. Nothing very extensive. So this one, which graph shows you this? Which figure shows you this? Which figure shows you y equals to 1 minus x? Which one? Figure what?
Figure 1.
Figure 1. Because it's a linear graph with negative gradient. Okay, you see negative gradient? That's why it's downward sloping. Okay, what about this one? Reciprocal even function. Which one? Figure 4, correct. No answer, right? Or at the bottom?
Yes, the second one.
Okay, then the answer is that, yeah, you're not thinking one.
This one.
So how would it
The
become?
second one is bigger too, right?
How will it become? This one is y equals to 1 over x power 1.
This one, it's not like the answers are right there.
That's why I just saw. I thought like, wow. Okay, where's the exponential? One very obvious one. Figure 2.
Figure 2.
What about
I didn't
figure
even notice
4?
the answers until
figure
I
4
saw
is
the
the
answers.
Okay, then never mind. We have done 1, 4, and 2, right? What is this? What is the power of x?
The x squared.
Square. Okay, what about this?
X.
X power 1, right? And then this one is x to the power of negative 1. So you must know the shape by looking at the power. Okay, if they ask you to sketch and they say this is 1, 1. So they are telling you the scale. So first thing you know is if you sub in x as 0, your y must be equal to 1. So it must pass through here. Okay? Second thing, When you sub in x as 1, you want to know whether it will pass by that point. So it will be 3. So you estimate 3 will be roughly here. So the second point of the graph is over there. So since it's an exponential graph, when you sketch, just make sure it doesn't pass through this point. It passes through 1 and it doesn't touch the x-axis. So this is an O-level question. They give you one dot there and ask you to sketch it out. This dot serves the purpose of giving you the scale. That means this is 1 unit, this is 1 unit. You use that to sketch. Estimate will do. No need to be perfect. Yes. Because I want to know if I sub x as 1, will I get 1 or not? Will my curve pass through this point? So when I sub in x as 1, I realize it's 3. It is right above it. So my graph must miss this point. Yes. Okay, some graphs will pass through the point they give. So they are using this to check your understanding. Okay, make sure you know. This one is an O-level question. X equals to 2 can. But you will still need to show me where this is. It is above. Then can. Okay?
On mine's are shrinking.
Yeah, only 5.1. 5.2 don't have. You won't see exponential curve. WA3, yes, slightly. But anyway, WA3, your A math, you will learn exponential again. So it will reinforce each other. Okay?
I don't know.
Okay. Why? Okay, one more time. When they give me this 0.11, they are giving me the scale. So I will go and mark out my 11. Next is, I know that any exponential graph, when I sub in x as 0, the y-intercept will always be at 1. So it will pass through here. The next point I want to check is if it passed through this point. That's why I sub x as 1. But I realize that my y is 3. So it will be roughly here. So this is the second point I draw. So when I sketch, I join these two together and that's it. Because if I need to know whether when I draw, it needs to pass through here or not. So that when I draw, because when they put the point there, they are trying to test me whether I know whether the graph will pass through that point or not. So that's why I sub in to make sure it doesn't pass through. Okay, Okay, next one. Shh. Sorry. Okay, this one. Shh. I just want to go through the part that is a bit different. So you see this one, they say solve this equation. It's like the suitable line question. So relate back to this. So first thing first, what do you think I need to do about this part? So I will shift my 2x to the other side first. So I make it here. Okay, then my 2x is here. My minus 2 is here. So I have one part of it done. What else do I need to add on the right hand side? Plus 1, right? So if I plus 1 here, I should add 1 here. So on the left, so on the right hand side, it need not always be on the left. So on the right hand side, this is my curve. That means the question wants you to draw this line, y equals to 2x minus 1. So this is the only part that you need to draw the additional line and then find the intercept. Okay? So this one I leave you to go and draw and practice on your own. Okay, but the tangent is the one that is new to you. We just had a long break. What nonsense. Okay, so tangent, I will address it in a while. I just want to address the suitable line. Okay, this one. Okay, this question has no suitable line. I realize. There's a typo here. Change to X. Okay, this question has no suitable line, but they ask you in a very different way. See, they ask you to draw the suitable line. They give the suitable line to you. This one given. Right? So after you draw, and then they say, can you tell me for what values of X is your curve greater or equals to your line? This is what the question is asking you. So because I never plot, I'm going to use Desmos to show you the graph, and then I tell you how to find the solution. Okay, so let me just write this equation out. This is my y equals to 11 over 2x plus 5. Okay, then I draw the line that they asked me to, which is y equals to 4x plus 3. So at this last part of the question, they say, can you use your graph to find for which the curve lies above the line? So where is the curve above the line? By your observation, when is the curve above the line? The left-hand side, can you see? Can you see this part? Your curve is above the line. This is where it is above, lying above the line. The green zone here is where your curve is below the line. Can you see that? So they say, can you tell me the range of values of X where your graph will lie above or at the line? So this point I want. Okay, let's say this is your X equals to 1.5. All the range of values of X from here to here will be where your graph is above the line. So what is the range of values of X that lies in this zone that will be above the line? The smallest one will be 1.5. The largest one will be, the largest one will be 1.5. The smallest value of X is 0. So all your X value must be trapped between 0 to 1.5. So that means I only want this part. Because they say only consider the values between 0 to 7. So this is the only conceptual understanding I need you to do. They don't specify, then you tell me the answer is X less than or equals to 1.5. Everything before that. Yeah. So if they never indicate this range, then your answer is this one. Okay? Can I don't, yes. Question. Yeah, I only wanted to show this one. Can you see how I got the suitable line? This was the equation that they asked me to solve. So I shift this to the other side, make it negative 2x. Okay, but my equation is this thing. So I need to plus 1 on both sides. So this is my suitable line. By drawing the line. Yeah. Yes. Okay, actually, right? Yes. Question what? 2.